Welcome back. Now let us take another numerical problem. The top 3 meter of the backfill has a unit weight of 18 kilonewton per meter cube and pi is equal to 32 degree. Top 2 meter is having the unit weight of gamma is equal to 18 kilonewton per meter cube and angle of interpolation pi is equal to top 3 meter, angle of interpolation pi is equal to 32 degree. Next, rest of the .5 meter backfill has a unit weight of 22 kilonewton per meter cube and pi is equal to 22 degree. For this condition, it is asked to find the active earth pressure acting on the wall and its point of application. In the problem, it is not mentioned anything about the water at the backfill, unless specified it is a dry backfill. So it is retaining a cohesionless dry backfill. For that dry backfill, it is dry unit weight, but there are two layers of soil. The top 3 meter layer having unit weight of 18 kilonewton per meter cube and the angle of interpolation is 30 degree. The bottom layer has unit weight of 22 kilonewton per meter cube and pi is equal to 22 degree. Now let us start calculating the coefficient of earth pressure and then the active earth pressure. As pi for different layers are different, we have to calculate the angle of interpolation. Let us consider the top layer as say H1 and the bottom layer as say H2. This is for our better understanding. And the unit weight of top layer as gamma 1, unit weight of bottom layer as gamma 2, pi 1, pi 2. Since it is required to calculate active earth pressure, let us calculate coefficient of active earth pressure. We have Ka1 is equal to 1 minus sin pi 1 divided by 1 plus sin pi 1, that is equal to 1 minus sin of pi 1 is 32 degree divided by 1 plus sin 32, that is equal to 0.31 and coefficient of active earth pressure for the bottom layer Ka2 is equal to 1 minus sin pi 2 divided by 1 plus sin pi 2, that is equal to 1 minus sin of 22 degree divided by 1 plus sin of 22 degree. Solving this, you will get 0.45. So leave sufficient space here to the right side of the diagram to draw the pressure distribution diagram. Then continue calculation. For the normal backfill, normal means there is no surcharge or inclined surface, always earth pressure at the surface is 0, no need to write here, it is understood. Next, let us calculate earth pressure at various levels. Whenever we come across layered soil system, it may be a dry backfill or it may be a submerged or water table at the backfill. So we have to consider the layer by layer or step by step. So we know that earth pressure at the top is 0. Next, earth pressure at 3 meter depth. Earth pressure at 3 meter depth is equal to Ka1 into gamma 1 into H1. Ka 1.31, gamma 1 18 and H1 is 3 meter. Ka1 is 0.31 to gamma 1 18 into H1. H1 is 3 meters. So for understanding, no need to write again this explanation. It is Ka1 into gamma 1 into H1. That is equal, directly you can write this value 0.31 into 18 into 3. It is 16.754 kilonewton per meter square. Next, after calculating earth pressure at depth 3 meter, we need to calculate earth pressure at the base of the wall. To calculate earth pressure at the base of the wall, for this type of case, means for the layered system, first you have to calculate earth pressure at the base due to the top surcharge, means top layer, by using the coefficient, earth pressure coefficient of bottom layer. So for easy understanding, first draw the reference line, draw the pressure distribution diagram parallelly. So we calculated earth pressure at a depth of 3 meter. Let us mark this here. So this value is equal to 16.74 kilonewton per meter square. Next, earth pressure at the base of the wall due to the top 3 meter surcharge. Earth pressure at the base due to top 3 meter surcharge is equal to, surcharge means we have to use gamma 1 into H1 is a surcharge pressure, that multiplied by earth pressure coefficient of bottom layer, that gives you the earth pressure, that is Ka2 0.45 times of 18 top unit weight, that multiplied by 3. This is Ka2 into gamma 1 into H1. This is very important. So earth pressure at the base due to top surcharge is equal to coefficient of earth pressure of the bottom layer multiplied by the surcharge pressure of the top layer. That is equal to 3 kilonewton per meter square. So you can see 16.74 kilonewton per meter square, and for using the same vertical pressure, surcharge pressure, if you calculate earth pressure due to this vertical surcharge pressure due to 3 meter layer, earth pressure will be more at the bottom, it is 24.3. So this value is equal to 24.3 kilonewton per meter square. Next, now you have to calculate earth pressure due to this bottom layer. Earth pressure due to this at the base due to the bottom 5.5 meter height. Next, earth pressure at the base due to bottom 5.5 meter, that is equal to earth pressure at the base due to this bottom 5.5 meter the fill, that is equal to again Ka2 0.45 into gamma of the bottom soil, it is 22 multiplied by H 5.5 meter. So, this is equal to Ka2 into gamma 2 into H2. Ka2 into gamma 2 into H, that is equal to 54.45 kilonewton per meter square. So, this can be marked here at the base. If you mark it proportionately, .45 kilonewton per meter square. So, this is the calculation of earth pressure at the base. First, you have to calculate earth pressure at the interface between the top and bottom layer. Then you have to calculate earth pressure at the base due to the top layer. Then earth pressure at the base due to the bottom layer. So, we got the pressure distribution diagram. This is not the regular geometrical shape. In order to calculate total active earth pressure, we have to convert this irregular geometrical shape into a known regular geometrical shape. If it is done like this, you can see one triangle, rectangle, another triangle. So, mark the pressure acting on the triangular portion as say PA1 and on the rectangular portion as say PA2 and on the triangular portion it is PA3. So, total active earth pressure acting on the wall is equal to sum of the earth pressures acting on this triangular portion, rectangular portion and triangular portion. Total active earth pressure PA is equal to PA1 plus PA2 plus PA3, that is PA is equal to PA1 is the area of the triangle, first triangle, it is half into base is 16.74 into height is 3 meter. Next, earth pressure acting on this rectangular portion is equal to plus 24 base into height 24.3 into 5.5 plus earth pressure due to this triangle half into 54.45 multiplied by 5.55. So, calculate this PA1, PA2, PA3 and write it separately, and that is helpful to us in taking moment due to this PA1, PA2, PA3 about the two to calculate the point of application of total active earth pressure. PA is equal to, so PA1 21.15 plus PA2 133.65 and PA3 149.74. Therefore, PA is equal to 308.5 8.5 kilonewton per meter square, or it is kilonewton per meter, that is per unit running meter. So, after calculating total active earth pressure, we can mark it. This is PA. PA acts at a height y from base by using Varignon's theorem concept. We can calculate the point of application of PA. What Varignon's theorem states? The algebraic sum of moment of all the forces acting at a point is equal to moment due to resultant force. Here the algebraic sum of moment of all the pressures PA1, PA2, PA3 about a point, means about toe point, is equal to moment due to this total active earth pressure. That is, PA, we know PA 308.5 multiplied by Y, that is equal to 25.11. Okay. So, moment due to PA1 is 25.11, and about this toe point, the perpendicular distance from here to here is 5.5 meter, and from here to here it is 1 by 3 times of 3. So, 5.5 plus 1 by 3 times of 3, PA1 into, so PA1 it is 25.11, that multiplied by 5.5 plus 3 by 3, h by 3. 25.11 is PA1, perpendicular distance 5.55 plus 3, 1/3 of h, 3 by 3, plus PA2 at its center of the rectangle, and it's about this point moment distance, perpendicular distance is 5.5 by 2, plus PA2 133.65 multiplied by 5.5 divided by 2, plus PA3 is acting here from the base, it is acting at height of 1 by 3 times of 5.5 h2. So, PA3 is 149.74, that multiplied by 5.5 times of 3. So, here the only unknown is y. Solving this we will get y. Y is equal to 2.61 meter. You can see here the top layer having the angle of interpolation of 32 degree, and the bottom layer is having the angle of interpolation of 22 degree. So, means this is a somewhat good soil, it is not good soil. Because of this variation in angle of interpolation, always the decrease in angle of interpolation leads to increase in the coefficient of value. The increased coefficient value leads to increase in the earth pressure. So, we can see here because of the smaller value of angle of interpolation of the bottom layer, there is increase in the lateral earth pressure at the base due to the top surcharge soil. So, we can write here pressure distribution diagram. Let us understand the problem first. A retaining wall with smooth vertical back is 10 meter high, retains a 2-layer backfill. Top 5 meter comprises of sand with pi is equal to 30 degree and unit weight gamma is equal to 18 kilonewton per meter cube, and bottom 5 meter comprises of sand with the pi is equal to 34 degree and unit weight is equal to 20 kilonewton per meter cube. For this condition, asked to find the magnitude and location of total active earth thrust and draw the distribution of active earth pressure distribution diagram. Active thrust is nothing but the total lateral active earth pressure, or active thrust is nothing but active thrust is nothing but lateral earth pressure. So, active lateral earth pressure. Here active thrust is nothing but active earth pressure. Now, let us consider the retaining wall of height 10 meter. Having the smooth vertical back surface, and this the retaining wall is filled with 2 layers of cohesionless backfill. The top layer top 5 meter layer of soil consisting of pi is equal to 34 degree and gamma is equal to pi 1 is equal to 34 degree and gamma 1 is equal to 20 kilonewton per meter cube. Similarly, the bottom layer pi 2, top layer is 30 degree and unit weight is 18 kilonewton, and bottom layer pi 2 is equal to 34 degree and gamma 2 is equal to 20 kilonewton per meter cube. No mention about the water table or water condition, unless specified, simply assume it as the dry condition. So, mark this top height as H1 for our better understanding, bottom as H2. So, leave space to the right side to draw the distribution diagram. First, calculate the active earth pressures for top and bottom layers. So, here Ka1 is equal to 1 minus sin pi 1 divided by 1 plus sin pi 1, 1 minus sin of 30 degree that divided by 1 plus sin 30 degree is equal to 0.33. Same way, Ka2 is equal to 1 minus sin pi 2 divided by 1 plus sin pi 2. So, values are, it is 34 degree, 1 minus sin 34 degree that divided by 1 plus sin 34 degree, you will get 0.28. So, increase in the value of angle of interpolation will decrease in the coefficient of active earth pressure. Now, as there are no extra soil above the surface, it is purely horizontal backfill and earth pressure at the top is 0. Now, earth pressure, let us calculate earth pressure at a depth of 5 meter from the top, from the surface. Earth pressure at a depth 5 meter is equal to, directly we can write now, earth pressure at depth 5 meter is equal to Ka1 into gamma 1 into H1. Ka1 we calculated is 0.33 into gamma 1 is 18 into H1 is 5 meter. Directly we can write, no need to write Ka1, gamma 1, H1 and those expression. We can write the numericals values directly. That is equal to 29.7 kilonewton per meter square. Now parallelly draw the distribution diagram also. So earth pressure at a depth of 5 meter due to the top soil is equal to 29.7 kilonewton per meter square. Next, same procedure as we adopted previously. Earth pressure at the base of the wall, to calculate earth pressure at the base of the wall whenever we come across this type of layered soil, first to calculate at the base, first you have to calculate earth pressure due to the top surcharge, then earth pressure due to the bottom soil. Next, earth pressure due to top 5 meter soil due to top 5 meter surcharge is equal to Ka2 into gamma 1 into H1. Surcharge is gamma 1 into H1 top due to top layer multiplied by Ka2 coefficient of bottom layer, that is 0.28 times of gamma 1 18 into 5 meters, that is equal to 25.2 kilonewton per meter square. This is Ka2 gamma 1 into H1. Now you can see there is reduction in the earth pressure at the base due to same soil, the top 5 meter fill. See here, pressure due to this top 5 meter at a depth 5 meter is equal to 29.7 kilonewton per meter square. When we use Ka1 is equal to 0.33. Due to same soil, if you calculate lateral earth pressure at the base by considering the top fill, it will be 25 point, that is reduction, because this reduction is due to the decrease in the coefficient value. So the earth pressure diagram will go back. So pressure at the base is equal to, due to top surcharge, is equal to 25.2 kilonewton per meter square. Next, let us consider now the pressure due to the bottom 5 meter fill. Next, earth pressure due to the bottom earth pressure at base, you can write at base, again earth pressure at base due to bottom 5 meter fill, that is equal to, here directly we can use Ka2 into gamma 2 into H2. Ka2 is 0.28, gamma 2 20 into H2 is 5 meter, that is equal to 28 kilonewton per meter square. Now, to draw the distribution diagram, we have to commence from the previous one. Earth pressure, it has come back because of reduction in the earth pressure here at the base due to the top surcharge, and continue from this point. It is 28 So, we calculated earth pressure at various level, and also we completed the pressure distribution diagram. Now, to calculate the total active earth pressure, consider the separated known regular geometrical shapes, a triangle, rectangle and a triangle. So, total active earth pressure, total active pressure Pa is equal to Pa1 plus Pa2 plus Pa3, that is Pa is equal to area of the first triangle, it is half into base 29.7, that multiplied by 5 meter height, plus the rectangle, the base is 25.2 multiplied by 5 meter, plus Pa3 is half into 28 multiplied by 5 meters height, 70.25 plus 126 plus Pa3 70. Therefore, Pa is equal to 25 kilonewton per meter square or kilonewton meter. Now, to locate the point of application of the Pa, so now mark this is Pa1, that we already marked in the previous case, Pa1, Pa2, Pa3. Let Pa acts at a height of y from base. Let Pa acts at a height y from base. So, same Varignon's theorem concept we are using here to calculate y, that is 270 into y, 270.25 into y, that is equal to Pa1 is 74.25, that multiplied by 5 plus 1 by 3 times of 5. 5 plus 1 by 3 times of 5 by 3 plus Pa2 126 Pa2 into the perpendicular distance is 5 by 2 plus PA3 70 into 1 by 3 times of for the height for triangle. It is 5 by 3. Solving this, we will get y is equal to 3.42 meters. So you can compare this problem and previous problem. In the previous problem, that bottom layer having a smaller value of angle of internal friction compared to the top layer. Hence, there was increase in the pressure due to the surcharge. Here it is the bottom layer having a higher value of angle of internal friction compared to the top layer. There is considerable reduction in the earth pressure by considering when we consider the surcharge. So this junction variation is important. So when the back of the soil is dry and back of the soil having the different layers, we can work out the problems like this to calculate active earth pressure and their point of application. Thank you.